Hi, this is Ken. How's everything going? Today we have another kata that is at 5Q. The question is directions reduction. Let's go through this description first. Once upon a time, on a way through the old wild mountainous west, a man was given directions to go from one point to another. The directions were north, south, west, and east. Clearly, north and south are opposite, west and east too. Going to one direction and coming back the opposite direction right way is needless effort, since this is a wild west with dreadful weather and not much water. It's important to save yourself some energy, otherwise you might die of thirsty. How I crossed a mountainous desert the smart way. The directions given to the man are, for example, the following. So we can see here are different ways of the given directions depending on the language. So in Python, I guess it will be the first one, most likely. You can immediately see the going north and immediately south is not reasonable. Better stay to the same place. So the task is to give the man a simplified version of the plan. A better plan in this case is simple. West. So let's go through this part. So first, the direction is north, and which is followed by a south. I think this pair are in opposite directions, so we need to ignore them. And also here is south with a north later on. And then I think in the result, there shouldn't be any directions in either north or south. Here we have a pair of east and west, so they can be removed as well. And the final result is west, as shown here. Other examples also prove that what we have gone through. I think the question is basically ask us to remove the unnecessary moves in the given list. So let's have a try. I'm not sure whether you are familiar with a built-in function that is called reduce, which basically take elements of a list and apply each element to a given function and try to go through all the elements and give a final result. I think we can use this function. I think we can use some help of this function to solve this kata. Let's have a try. So first we need to import this function. It's in functools reduce. All right. Here we have a given list which is called array. So reduce, apply a function. Let's call it simplify. Even though we haven't defined it yet, but we just put it here as a placeholder at first. And we put array here, so each element of array will be taken by this function simplify. And we give it an empty list as a start point. So what I want to do is to use this empty list as a start point and take each element in this given AR and try to figure out whether a direction should be kept or removed. So how can I do it? Define, simplify. We need two directions, of course, because this function is used by reduce. A and B, let's see. Even though I'm using A and B here, but I don't really recommend you to use this unmeaningful variable names, because in a long script or program, you don't forget what a variable is and what the variable presents afterwards. So, but here this is quite simple and short, so I think it's okay to use it. Okay, so what we'll do is to say if B is north, what we want to do is to say, okay, let's remove south from the list, all right? But the problem is that what if there isn't a south in this list? Then we need to add north in it, right? So simple. How can we do it? Let's use some ideas from yesterday. We can say try except value arrow B. So what this part of code does is to say if the directions taken in is north, then it will try to remove south from the existing list at first. If there is a south, then it will be removed and return the list directly and skip this part of the code. If there isn't a south in the list, then the code will raise a value error, which will be caught here, and then we know that we need to append this new direction into this list, right? So we have one direction done. So let's just copy and paste and change the direction accordingly. If it's south, then we say we try to remove north first. East, then it will be west. If it's west, then we remove east. So I think we got what we want here. But remember, in Python 3, reduce returns iteration in default, so we need to convert it into a list, and then we just return it. All right, let's have a test. Seems like we have some errors here. Let's try to figure it out. So here we have an empty list, but the expected result should be northwest, south, and east. So it seems like this south coming later shouldn't cancel this north, and also this east shouldn't cancel this west. And let's see east, south. This is the result we got from the test. And in this test, the expectation was this. From what I can see here, so this south shouldn't cancel this one, and then this one shouldn't cancel this one. All right, let me go back to the instructions and try to figure out. All right, it says you can immediately see the going north and immediately south is not reasonable. So I think we should interpret the example as this. So first read north in the list and south, so they cancel each other, and south and east and west, so they cancel each other. Okay, then this north cancel this one, and then the west is the only element left in the result. So it seemed I got the right answer in the example, but by using the wrong method. Okay, I think this would be a simple fix. To determine whether this is a immediately opposite direction or not, we only need to say what's the last element of the list, right? So we can say if the last element is south, then we remove south, or we just added it back. Because we already have this conditioning checking, we don't need to have this part. Okay, so here, if the coming direction is north and the last one is south, then we just remove it. If not, we can directly add this new direction into the list. And this also applies to the rest of the directions. Let's keep fixing the other three directions. So if here is south and the last one is north, then we say, okay, we remove the last north and or we appended it. Right. Let's have a test to see whether our fix. Wow, right. Seems like I ignored another possibility here. So if the given list is empty, so we just need to append it and return and then return it. So we don't need to go through this part. And then let's have a try. Alright, it seems like we have a new issue here. Have you noticed how many south here? 1, 2, 3, 4, 5, 6, 7, 8, and we have 2 test cases here. Right? So it seems like for each south in the test case, we have 4 added in the list, which shouldn't be like this. Let's try to figure out why it was like this. Okay, so after the first element north in the test case being pushed in the list, then this is the second one, south, get into this function, and in this condition, A is the list with a single element north as the last one, and B is south. Okay, when the code runs at this line 8, so obviously this conditional checking will fail because B is south. Okay, then the important part is here. South will be appended to the list at this line, even though this part is true, but since the last element is not north, because remember, and the previous line 11, the last one, line 11, south has been appended as the last element, so this part will also fail. Then it will be appended again and again and again. So how could we fix it? I can propose you another simple fix by doing return and anywhere. Okay, then we have this. What the code does is to say it has several different conditions, and each condition it will behave accordingly and then return the list. Do you think this will work or not? Let's give it a try. Alright, it seems like we have fixed one issue here, but not the other one. The first thing we can do is to remove some parts of the else. Have you seen this part? And the error is also caused by this part because after the first one is here, then the second one will come to here. Then the test will fail, and then we will directly go through this part. And then the function will return the list, so the rest part of this function will never be executed. As you can see here, we have a lot of A appended B and return A within the else branch. So what we can do is to say, okay, let's remove all of them. Easy. And use else if after having this small change of the code, there are 4 conditions, but only one of them will be executed at a time. Have you also noticed there are a lot of return A happening here and there? What we can do is to remove this part and use this a single return A to replace all of them, because this part of the code can be considered as one only one of the conditions of this five will be executed. So this is another optimization we have. All right. So how about this part? This part checks whether is empty or not. If A is empty, then add the direction into the list and return it. I think we can use another way to say it. So when it's empty, we appended it. Then we don't need this part because if it's empty, none of this will be true. So we can direct skip all of them and do this. Also, we don't really need to use equal empty list to check this empty or not. We can say not A. So when A is empty, it will be false, and then not will revert it into true. So we can simplify it as this one. Cool. Don't you think this is simpler? And also works better. But have you seen any other issues in the code? If not, then I can give you a small hint. In each direction, it will remove the opposite direction, but this will remove the direction from the first of the list, not at the end of the list. But actually, what we want is to remove the last direction we have in the list instead of the first one. So what we can do is to do pop, which returns the last element and remove it from the list. Let's see how it works. And it works perfectly. Don't you think this is actually easier to write and read instead of the crappy code I presented earlier by adding more and more temporary codes into each branch? And also, you can notice that the version here is 3.8. In 3.10, there's a new function in Python which is called a pattern match, which is actually simpler in this case. If you have any interest, you can check it out. You definitely will love it. Let's submit it and head to the next kata.